Here's an overview of Chapter 11. There's 11 sections to Chapter 11. Arrays hold multiple values and so on to a standard template library of vectors, which we'll learn about. Notice that 710 is not in this list. So 710 is optional. We don't have to look at 710, and you won't be expected to know the content of section 710, but we do need to know all the other contents. We're going to start with 7.1, arrays hold multiple values. That's where we're headed. And here's our slides. Chapter 7, arrays and vectors, and a blank area over here. So 7.1, arrays hold multiple values. An array is a variable that can store multiple elements or values in it. So here they're declaring an array that holds integers. This array is called test, so that's like the name of the variable. This test holds 5 integers. 5 is the I don't know what that's called. It's the number of elements in the array. So when we create this, it creates a area in memory that is continuous, that has 5 integer-sized bits of memory. So each of these memory bits here is an integer size. We can access the very first element with tests of 0, and then so on. So let's talk a little bit about indexing into an array. Let me do this on the board. I'm going to pause here. So I just showed everyone how the indexing works here. So int tests of 5 creates or declares in memory an array of 5 integers. And we can index into it using the same kind of syntax as the declaration, but it is an offset from a base address. And so we'll see that. So let's back up a slide. Arrays are variables that can store multiple elements or multiple copies of the same kind or the same type of variable. In our example here, we're storing 5 integers in the tests array. In memory, all those integers are consecutive. And so it's one big block of memory. It's 5 integers long for a total of 20 bytes. Each int is 4 bytes. So we have 5 of them. We have 20 bytes of memory there. In the definition or the declaration for the ints, int tests of 5, the int is the data type, test is the name of the array, and 5, they call it size declarator here, which tells you the size of the array. The size of an array is the number of elements times the size of each element. So the size in bytes will be the number of elements times the size in bytes of each element type. In this case, we have an int. An int has 4 bytes, and so tests has 5 ints in it for a total of 5 times 4 bytes or 20 bytes total. We see here 20 bytes total. A long double measures, so here we have a long double, so doubles are normally 8 bytes, and a long is also 8 bytes. So a long double, 8 bytes each, measures of 10. So the size declarator is 10. Measures has 10 long doubles in it for a total of 80 bytes. 8 times a long double size, or 8 tens, which is 80. Named constants can also be used for the size declarator. So let's play with that, see what we can use for size declarators, what we can't use for size declarators. So I can create a new project for our chapter 7. And I'm going to pause to do it really quick like magic. And we make a new file for this. So we want to test size declarators and declaring integers. So I'm going to need main for that. So I'm going to make a main. Return 0. And we want to print stuff. So we're going to include IOStream. And we're going to using namespace standard. Alrighty, so let's play around with this. We're going to make some arrays. So we saw earlier we had an int tests, and it has 5 things in it. So what else can we do? Int, let's say a equals 5. Int tests 2 of a. We'll compile. And we get two warnings, says two unworded variables, tests and test two. Now this one here should have failed because A can be changed to any number. And it should not allow us to declare an array using a variable. But it did. So let's see if we can put stuff in there. And let's see if we can print it out. All right, so let's take a look at this bit of code I just threw together. I'm creating an array called tests2 of 5 integers. I made A5. And then I run a for loop. The for loop loops from I equals 0 to 5 exclusive. So I do 0, 1, 2, 3, and 4. And I'm taking that index, 1, 2, 3, 4. Oh, I did an error here. There we go. And sticking it into each element of tests2. Then we print out each element of test2 and see what happens. Whoopsie. We get a warning, says tests is not used, which is true. And we run it. Local application. Nothing to build. I assume, what is it? Norton's having it say. Hello. Or Norton. Nothing. Why isn't it running? Oh, here you go. There it goes, because Norton was having it say. Okay, 0, 1, 2, 3, 4, so it worked. In my time when I learned this, it would not accept using a variable as a size declarator. But here it did, without trouble. So here on the back to the slide, it says named constants are commonly used as size declarators, and I'll show you why. Here I'm using a magic number 5. So I have a 5 up here, and I have a 5 here, and I have another 5 down here in the for loop, and another 5 in this for loop. Suppose I change my mind. I want to make tests 7. I could change the 7 here, then I'd have to change it here, and here, and all over the place, right? I'm changing that 7 all over the place. But what happens if we create a constant int? Int constant size equals 7. Then all I need to do is put size everywhere. That I have a 7. And now if I change my mind, oh, let's do 13. I just changed it in one place, right? 13. Oh, let's change it again. Let's make it 8. One place. And so now I'm changing that index, the size of the array, and indexing into the array, right? I'm doing that all over the place with just one change rather than changing it wherever I use it. And instead, I use that constant constant variable wherever I need to change the size. So that makes it easier to control where the size is making. Let's see if it works. Same error, that test is not in use. Run it. Let's see if it runs faster now. It did run faster. There we go. So there is 8 size array. That's the last bullet point. Eases the program's maintenance because we only need to change that number, the 8, in one location. And it will automatically carry through wherever I need to use my array. I can get rid of tests because we have tests too. There we go. So that was 7.1. So again, the syntax to declare an array, we have it here, is the data type that's stored in the array. In our case, it's int. The name of the array. In our case, it's tests2. A open and close square bracket, and a size declarator that tells us how many elements are in the array. In this case, it's 8. So let's write that down as comments. array declaration syntax, and it is return type, followed by the name, followed by a square bracket, followed by the size, followed by another square bracket. And we see that here. We got our int, return type. The name is tests2. Notice I can put spaces between the square brackets. Our size, in our case, is the 6. And we got our close square bracket. Okay. And notice C++ doesn't care if I have all those spaces in it. So there's the syntax. That's how to declare an array. 7.2. Accessing array elements. I did a little bit in this for loop, but we saw that an array is just a whole bunch of variables with the same name. And in order to access each one, we're going to use a subscript. So I do that here on both lines 18, a subscript here, I, and on lines 22, subscript here, also an I. And that will access each individual element. So let's do that. Let's access an individual element. The for loop on line 17 fills the array with the numbers 0 through the size -1. So we get 0 to 7 in the array. And we see that printed in the second for loop on 21. See. Fill the array with 0, 1, 2, and so on up to 7, and then print the array. Okay, so let's access a single element. To access a single element in the array, just like it says on the slides next to us, we use a subscript inside the square brackets. Let's do that. Let's make our first one the number 13. So we have tests2 is the name of the array. We want our first element, that's at index 0. It's going to get the value 13. 13. So that's very much like using a single integer, right? It's like saying int b, and same thing as b gets the value 13. We can even say something like int tests2 sub 0 gets the value 13. So all these are equivalent, except we just have one array that we can run through and use the same variable name for each element in the array. Whereas test2, I'd have to make another variable for tests3, tests2 number 1 gets the value 1, and so on. Tests2 number 2 gets the value 2, and so on. So it's a lot of typing that I'm avoiding by just creating the array tests2. So I avoid this. I don't really want that, so I can get rid of it. I don't want B, so I can get rid of it. So we saw how we assign to an element in an array, assign a value to an element, and we can also get an element out and assign it to another element, such as tests2 of 3 gets the tests2 of 0 value. Now I put 13 in 2 locations, in the first one and the fourth one. So let's see if that worked. I can grab my printer, and see what I got after I've done these assignment statements. And let's run this and see what happens. So I have an int b that I'd never use. Where did I make my int b? Int a, int b right here. Let's get rid of that. And let's run this and see what happens. So there we go. And let's make them fatter. Here I have like 2 digits. Let's use a size of 4 for the print. Set width 4. I think that's right. Set W4. And here's my other print. Set W4. And we need our IOManip for that. I'll include IOManip. And hopefully this will make everything prettier. Let's see if I can make it pretty. That's all I'm trying to do. I'll put all those outputs in the same 4-space area. There we go. 1, 2, 3, 4, 5, 6, 7, 8. 8 elements in the array. We can see the first time I have the array is 0, 1, 2, 3, 4, 5, 6, 7. The very first element has the value 0 and so on. And then with our 2 assignment statements, I'm assigning the value 13 to tests of 0, test 2 of 0, which is our first element. So it gets 13. And then I'm assigning whatever is in test 2 of 0, that's our 13, into tests 2 of 3. So 0, 1, 2, 3, that goes right here. So the second 13. In short, we can use each element in an array, like we see over here, as its own variable. And to do that, the syntax is the name of the array. Where's the syntax? Here we go. The name of the array, square brackets, and an offset or an index into the array. So let's write that down as how to access it. To access one element, use this syntax. Name, square bracket, index, close square bracket, and then here we're assigning a value. I can spread these things out. Square bracket, index, close square bracket. Let's line that last close bracket up. Equals value. There we go. And let's get rid of our B because it's in the way, right? It's ugly. Ugly, ugly. Don't need that. That's how to use the array. So we've created it. We've put things in it. We've taken things out of it. And that's basically it for an array. So the beauty with an array, we can see that in this for loop, is that we can access multiple elements in the array with an index. Here I'm using my for loop to change the index to go from 0, 1, 2, 3, 4, 5 up to 7. And so that index is an offset into the array like we saw earlier. That allows me to access each element in the array. And I can do it in turn. And we saw earlier up here where I filled the array with the numbers 0 through 7, that I used the index itself to put that value into the array, accessing the array using the array name and an index. And that's the power of an array. So you can hold lots of things. Let's take a look and see how the textbook uses an array. So here they're making an array called hours, and hours is going to hold the hours for each employee. So then in their code, they're asking the poor data entry person to enter 1, 2, 3, 4, 5, 6 different hours, which happens to be the number of employees. The prompt for the poor data entry user is enter the hours worked by blank employees, where blank is the number of employees. So here we see that constant int again, num employees, and we set it to 6, and we make the poor data entry person enter the number of hours 6 times. Do note that the hours is an integer. I probably have made it a float. So these employees cannot get fractional hours. They have to work full hours. So here's the output. In the output, they're just printing out those hours as if they were single variables. Hours of 0, hours of 1, hours of 2, and so on. So I will say the name of the array, hours, and then of to say the index. So the element is hours of 0 is the first element. Hours of 3 down here is the fourth element, and so on. Here's the program output. Enter the hours worked by 6 employees. They did it in one big glob. Notice they did spaces between their ints, and so each space is using a single cn to fill it up. If we go back one and look at the thing, each cn grabs one of those integers off that whole line of integers the user typed. User typed 6 integers, 1, 2, 3, 4, 5, 6, and puts those into the 6 spots of the array, the 6 elements of the array. Here we see accessing array contents. We can print from it, so we can read it. We can get out and do something with it. I did that. Where did I do that? Right here, line 37. I get a value out on the right, and I put a value in on the left. So I'm taking what's in tests2 of 0 and putting it into tests2 of 3. So just copying a value from one element of the array from the first element of the array to the fourth element of the array. So you can read it for reading. Here's reading. We're going to use it for writing. Using a loop to step through an array. We just saw I did that 2 times. Here to print every element, I have to loop through it, each element in turn. And so I need an index to each element. And the easiest way to get that is a for loop. So you'll see a lot of use of for loops. Also notice in both mine and the textbook's use of the for loop, they're using that constant int. So here's array size as a constant int. And they use it both to create the size of the array here and as that checker, a conditional. Right here we keep incrementing our index, our count, until it reaches the array size and we stop. We use it in 2 places. We only have to write that 5 in 1 place. Makes it easy. Here they're looking at the loop. I've gone through the loops. In other words, I'm creating a loop variable I for the index. It starts at the value 0, so I initialize it to 0. Then whenever I is still less than the size of the array, I do the loop. In the loop, I'm printing out what I find in the array at index I. So it'll do 0, and then 1, and then 2. And after I print out that one element, I increment my I, so we move on to the next element. Eventually, I becomes the same as size, and I don't do my loop anymore. I quit before I gets to size. Okay, what I'd like everyone to do now is to make an array to count to 10. And so I'm going to stall this. Going to take 2 minutes.
In Python for like yourself. When we're doing it, we have to run a for loop every single. I mean, like a very long for loop to create every single variable. And then first we have to read in a number, and then we have to create it. And then here it's just figure it.
Yeah.
So it's fun.
All right. Very good. All right. So, ladies and gentlemen, we just saw how to make the array bigger and bigger and bigger by just changing that size. And you can run that. Like here, I just changed it to a size of 8,000. Actually, 8,000 is a little too big for a demonstration. I can make it 80 just for brevity here. But once we make it 80, we can run this and see 80 numbers spew out the back. I mean, Norton lets me do it. Norton's mad. There we go. 80 numbers. Look at them all. Keeps going and going and going and going in one big long line up to 79. That's correct. 0 to 79. 80 numbers. Very good. So let's go back to our slideshow. We saw the loop. Default initialization. So this is just like our standard variables. If it's global, it's going to initialize all elements to 0. And if it's local, it will not initialize them. Really? Let's find out. So we're going to make a global one. We're going to make a local one and see what's inside. So let's move our size outside of main so we can use it both globally and locally. Now we're size outside. We're going to make an int array. I'll call it global test of size. I can spell properly. There we go. And then we'll have our tests2 still. We won't fill tests2 up. So I'm going to turn off my filler upper for loop. And we'll make our size back down to something manageable, 10. And then we'll go print tests2. And on the next, or the first line, we'll print our globals. Actually, I want them on separate lines, right? So I need separate for loops, one for each. Wow, I'm copying and pasting this for loop again and again and again. What could I do to make things easier for me? Any ideas? Global test or global test? It's global test.
Like that as a variable?
Like my for loop as a variable?
Oh,
Yeah, I keep typing the for loop again and again and again. See, it's up here, global test, and then test 2. I have it right, 2, 1, 2. 1, 2.
I mean, it isn't a bad idea.
Yeah, right. So how do I do that? What do I do? I'm gonna hide. I'm gonna leave that one. It's fine. How would I turn that for loop something?
Um,
Don't remember?
um,
Oh well. I'll let you guys think about that. I'll run this and see if it is indeed filled with zeros and uninitialized. All right, so the first one to print is going to be tests 2, and the second one to print is going to be global tests, and then the third one to print way down here is test 2 again. And what are these big god awful numbers? Have these areas been initialized? No, they haven't. Wah, wah, wah. But notice the global one has been initialized. They're all zeros. So again, I printed my global one second, and it did indeed initialize everything to 0. And my local one was not initialized. So beware that whenever you have an array, you'll probably want to fill it up with your default values, your empty values. So pick some value and fill it up. Usually we do 0 to fill up. So here's my filler again. I'm going to uncomment my filler. And instead of filling up with the value I fill up with zeros. So now let's do -1 so it looks different from my global. And now they've both been initialized. One implicitly, the compiler initialized global test for me, and then I explicitly initialized my test2 array with a filling loop. And when we run this, my -1s for my local and the zeros for the global. For initialization, we can also use what's called an initialization list to initialize an array. So let's make a new array and use an initialization list. I'm going to move all this code into a how to declare function. Void how to declare. And I'm going to grab this function I just declared, copy it, paste it down here, paste, turn it into a real function, curly braces, grab all the code I just put in main because I want to clear main out. So we can grab all the code out of it. Gobble, gobble, gobble. Except for the return, right? Return belongs to main. Control X, all gone. How to declare, Control V, paste it in. And we're going to test to make sure it works by calling how to declare in main. Notice I didn't quite spell how to declare properly. How to declare, no E on that. And it should do exactly the same thing it did before, but I just moved the code to its own function. And this makes it easier for me to control which functions to run in main and which not to, and it makes main so much cleaner. And I can click the little minus sign here to hide all the innards of how to declare. Look how clean and pretty that is. Next one. Arrays can be initialized with an initialization list. So let's do that. We'll do it in main, and then we'll move it out of main. So notice on the second line of the slide, they say int tests of size, and then you put the values out there. I can put the size explicitly in the array itself. And we have a curly brace, and we have values, 79 and 82. We can put any values we want to there, 99, a minus 23, and a 12. Close curly brace and a semicolon. Notice that I have 1, 2, 3, 4, 5 values in the common delimited initialization list, surrounded or delimited by curly braces, ending with a semicolon, and I'm assigning that with the assignment statement to our array. Let's try that again with a different array. Int tests 2 of 5. But this time, I'm going to try to assign it tests 2 gets the values 79, 82, 99, minus 23, and 12. Right, I'm trying to do the same thing twice. And when I try this, let's see what happens. So he gets, oh, it got mad at me. It says, error, assigning to an array from an initialization list. Well, maybe I need the 5 in there. All right, test 2 of 5. And I get the same error. Cannot convert brace enclosed initializer list to an int. So it only works when you declare the array. It does not work any other place. So that's called an initialization list, and it only works when you declare it. It has to be done in the same line that declares the array. So here I'm declaring an array and initializing it in the same statement. And that's the only place we can use initialization lists. The values are stored in the array in the order in which they appear in the list. So the 79 is going to go in the first element of the array, and so on. We can see that by printing out the array. I'm getting tired of writing these for loops, so I'm going to write a print array. If this were Java, we'd have an arrays, but this is not Java. So I'm going to make my own thing. So void print array, close square bracket, int, square brackets, and let's use our size again. We'll make size 5. This is a bit of a cheat. Let's do it better. Let's do it this way. Int size. Int array. It's like R. Is that how it's done? We'll find out. And then we go to my print statement, how to declare. We're going to ignore you. Click. It's like I'll print array. Void print array, square bracket, int R, square bracket, colon, int size, and we do our for loop for int I equals 0. I is less than size, I plus plus, and we see out R of I and a space, and then we see out our end line. And let's put set width in here. Let's do 3. Set W. All right, let's try it out. So I create an array. Let's see if I can print it with my print array. This is tests, and it's size. Please work. No errors compiling. Run it. And it worked. Look at that. Voila. So now I have a function that does my printing, and I don't have to type this for loop ever again. It takes the array to print. Notice no square brackets on it. And how many elements are in the array? Perfect. All right. Values are stored in the array in the order in which they appear. So the 79 went in first. 79 comes out of the array first. And so on. The initialization list should not exceed the array size. What happens if it does? I don't know. Let's find out. 90, 92. So now my initial, it gets an error. It says, too many initializers turned into 5. Wah, wah, wah. So it doesn't like me. And when you're learning C++, again, I highly recommend that you play with it and try to make it do, like if they say you can't do something, try it and see if you can do it. All right, what's next? Here we have a program, and I did this on my own, right? They did days in the month. So there's 12 months, 0 through 11, and they're adding days in the month. 30 days has September, April, June, and November. All the rest have 31 except for February. When it's done, 28 days have come and gone, except for leap year, 1 day more long, or something like that, which is the old rhyme that they used in the Middle Ages so that the peasants would remember how many days were in each month, so they knew when to plant. 30 days has September, April, June, and November.
What?
All the rest have 31 except for February when it's done. Okay, sure. 30 days has September, April, June, and November. So they're trying to rhyme so you can remember it, right? All the rest have 31 except for February when it's done. I think 28 days have come and gone, except in leap year, 1 day more long, or something like that.
We just go the old January.
Oh, I didn't notice that one.
That you got January, so all the ones like on your knuckles are
Yes.
31. Okay, and then the ones in the crevices are 30. So
Oh,
January, February, March, April, May, June, July, and then August also starts on 31. So you got August, September, October.
wow, that's a cool one. I didn't know that one. Thank you.
It's easy for
Um,
kids to
okay,
remember.
okay. All right. So here, partial array initialization. Now, if the array is bigger than the initialization list, it will still work, but the rest are set to 0. Really? Even if it's local? Let's find out. I think it's a liar. So I'm going to make my array bigger, 10, and we're only going to put 5 elements in it and see what happens. Okay. Okay. I was right. Yeah, well, they had the 3 estates and they weren't literate. You're right. And so one of the things that you see in church, if you go to church sometimes, is they'll say something and then everyone repeats it. And you see that same kind of the Psalms and stuff. Same thing there. So the people were illiterate; they couldn't read at all, but they could repeat what someone else told them. So it's one way to, I guess, get them involved with the liturgy. All right, here we go. So I've made a size 10, and I want to see what happens if I don't fill the entire array up. Save build. It says it makes some zeros. Is it a liar? Let's find out. Nothing to build. I guess I built it already. Here we go. It does. Look at that. The remainders are 0, even for a local array. Can you put like 2 commas in a row? Comma, comma. Oh, it's mad at me. You can't. We need some kind of expression between the commas. Okie dokie. What's next? Can determine array size by the size of the initialization list. So we can create arrays without specifying the initialization list. So here in the slide, they say int quizzes, square brackets. Notice no size declarator within the square brackets. And then they make an initialization list. So we can set the size in that manner. Int more stuff, square brackets, and more stuff is going to be the values. Curly braces. There we go. Oopsie, curly braces. There we go. 1, 2, 3, and 4. Curly braces. And then let's print more stuff. We know it's size 4. More stuff, comma 4. So here I have to remember it's 4. I have no size to tell me how many elements to put into the array. 1, 2, 3, 4. So there's creating or declaring an array without an initialization or without a size declarator. Can declare an array without a size declarator by using an initialization list. There we go. I can put my printers here and my return 0 there. So we're going to separate what we're doing here. Let's either use an array size declarator or initialization list. So you can't do just one of them, right? We tried that with making too many fit in the array, and that didn't work. And we did too little. That does work. But what we can't do is just this. Int even more, square brackets, semicolon. That's what it says we can't do. And they're right. Look, even more isn't known. The size of even more isn't known. So it needs to know the size. And that's when you declare the way. Notice when you declare the parameters, they don't need to know the size. But it does have to find the size somewhere. So I pass the size in here. And I thought there was like a pretty trick to do that. Let me try something else here. Int s equals size of r of 0. Size of r divided by size, oopsie, divided by size of R of 0. See if this works. It's mad. It says unused value S, and so then we'll change size here to S and see if it works. Size of R returns size of int star. I'm going to get an error here. Let's try it. Nope, only 2. Wah, wah, wah. Doesn't work. Okay, so I can get rid of that and put it back to where it was. All right. 7:3. Where are we? 7:30. So we've been going for about an hour. We did take a little break with the count to 10. Bounds checking. Notice there's no bounds checking in C++. So up here I did an initialization list. I have a for loop, and we're going to put more stuff into more stuff than more stuff can take. We're going to try. So more stuff of 5 gets the value 5. Can we do that? It's happy. 1, 2, 3, 4. Well, that's because I passed the value 4 in here. Can I pass the value 5 in here? I can. Look, it found a 79. Where's that from? We can make it even further. How about 6? 79 and then 5. What's going on? And how come it's a 5 here? Where'd my 82 go? So do note that C++ has no bounds checking, and that means it doesn't know where the array stops. So over here, I'm creating a 4-element array called more stuff. It has 4 elements in. And I'm creating a size element array which happens to have 5 things in it. Then I'm writing to the 6th element in this 4-element array. See that? So the index, one more than index is the element number we're writing into. So I'm writing into more stuff of 5, which is the 6th element. So I go 1, 2, 3, 4. Then I go to this empty spot right next to it, and I go one more even to the empty spot there. But more stuff doesn't have those empty spots. It stops here at number 4. And so it keeps going. So in memory, we might show you what's happening in the memory. It's very cool. Look at C. I want the number 5. More stuff of 5. Where's more stuff of 5? 0. So far I've stayed within my stuff, but maybe we can jump to more stuff of, I don't know, 60 and see what happens. And we'll run this. So there's a bunch of zeros, right? So here we have my, what's the next array I have? Tests. So here's my tests. 1, 2, 3, 4, 5. Then I get a bunch of zeros. I got the 16, and we got some uninitialized stuff. I have no idea where the 16 is from. It looks like what I did before. We get a bunch of zeros, and we keep going. They're all zeros. What about more? Let's do 600, and let's modify my for loop in the print array to print in groups of 20. I said 20. We're going to print 600 things from more stuff, or at least try and see what happens. Oh, look, you got something. The instruction at blah, 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 reference memory at blah, blah, blah. The memory could not be read. Click OK to terminate the program. So try to read outside the memory that was given to me with a 600 ints, which isn't very much. And then down here, it looks like it ran happy and didn't crash. So Norton crashed it, but down here it ran happy. And it gave me 600 ints. And we can see that there's some stuff in there. I don't know what this stuff is, but I can print memory that I'm not even using. And C++ will allow you to do that. So there's no bounds checking when you use subscripts to access array elements. Do be careful because you can crash your computer. You can get blue screens of death by messing with memory that's not yours. And then you just have to restart your computer. But it's fun. So I'll wander around. The other things we can print them as characters. So print, let's call this print I array for integer array. And then print C array would be the characters. Void print C array character R square brackets int size. Instead of an integer, it's a character. No, just grab this guy. Paste him again. Change that I to a C. Change this int to a character. And we're good. Print array is not declared in the scope. It's print I array now. Cannot convert int star to a character star. Where? More stuff. Ah. A cheat. Oh, there we go. Stuff. Anyone ever see weird stuff like this before? You have? Where? On accident. Okay. So what you're looking at is the character representation of a binary file. And so binary, in this case, we have ints. Ints have 4 bytes in 2's complement. So the ones and zeros get decoded to make an integer. But here we're trying to decode them to make characters, looking them up in the ASCII table. And they don't match. So I can go in there and find stuff. And it didn't crash. Let's see if we can make this even bigger. Yes. So it's a binary file. At some point, I'm going to escape my memory, and then it should crash. Like Norton's mad at me. But what's this? Eclipse doesn't care. Zero, a bunch of blanks. Some more stuff down here. That's it, right? Nothing. And for this character, let's make this a 2Z. Okay. So if you want to play around with the memory and see what's there, you can. I suggest doing it in the characters. So here we're casting to a character star more stuff. More stuff is an integer star. All right, enough of that. Enough playing. Let's keep going. What does the code do? So we have allocated or given ourselves access to a declared area. Here's values of 0, 1, and 2. We say this is our memory. But C++ does not look to see if we're stuck in the memory. Right? We can go above where we want the memory or even below where we want the memory and write or read from that memory location. Or we're writing or reading the type of array that we have. So here with tests, we say it's an int array, so I'm writing or reading ints. Same with more stuff. Although down here when I'm printing it as if more stuff was a character array. So I can see what the code is in there. I want to see more. I want to see 60,000. Now, Norton gets mad at me. But Eclipse did not. Same thing here as before. Nothing really fun. Just blank. Blankness. Oh well. All right, I give up on that one. No balance checking in C++. Be careful. Do not go beyond your array size. Again, remember that the subscripts for the indexing are 1 less than the total size. So here, more stuff has the values 0 to 4 for indices. To 3, sorry. There's only 4. And tests has the indices 0 to 4. So if you go below or above the index range, and n. You can read or write to memory belonging to another program or variable. Which is dangerous. Whoopsie. There we go. Danger. Okay, okay. So the worst that happened on your own machine is it stops working and you have to restart the whole machine. I don't think it will write to the swap file, so I think you're good. Off by one errors. This happens all the time for beginning programmers. Notice what they have down here. They have for int count equals 1. We're used to counting starting at 1. But the indices in an array starts at 0. And so that will goof up beginning programmers. They'll always write, oh, this is the first element, 1. This is the second element. And when they print from elements 1 through 5. Right? So if we look at this array here, tests has the indices 0 to 4. But if you write it to print into and then print from, right, you enter 1 through 5, C++ will happily do that for you. For example, here, I'm writing more stuff of 5, and more stuff doesn't have a 5. It has a 0 to 3. But it happily writes to the 5. And as we saw in the output, let me stop this character printer. There we go. Oh, Norton's happy. I wrote that 5 right here into tests, but not more stuff. And so I'm writing the memory that's in a different array. So weird things can happen. But if I'm just printing more stuff, I don't know. It looks the same, right? Print the numbers 1 through 4. So I can do that. Let me show you that. For int I equals 1, I is less than or equal to 4, I plus plus more stuff of I gets I. So I'm putting in one of the numbers 1 through 4 into more stuff. And let's get rid of this one here. One, one, two, three. So I use the initialization list. I put that 1 in there. This could be anything. Let's do minus 99. 1, 2, 3. Notice where the 4 is. But if I print it, it looks normal, right? So here I'm putting it in. I'm just printing it. 4 int I equals 1. I is less than or equal to 4. I plus plus. See out more stuff of I and a space, and then see out end line. I'm using round indices. I'm putting the numbers 1 to 4 into more stuff, and when I print it, the numbers 1 to 4 come out. It looks like it's working. But under the hood, it's not. You see that? So what's happening is, I'll go back to my picture over here. are. It's not working right. Why? I don't know. All my code is correct. It looks correct. Something's wrong. So do beware of off by one errors. Indices always start at 0. Very first element of array is at index 0. The very last element of array is at index the size of the array minus 1. If you've got to the size of the array, you've gone one too far. These off by one errors happen all the time. All right, I think it's time to play with this. So let's take a look at one of the labs and see if we can play with it now. We have the range-based for loop. We'll get back to that. Let's play with it. So I'm going to stop my lecture thingy here.